So you look at these two timing specs, okay, and one of them is a killer that keeps you up at night if you're an integrated circuit designer, and the other one has to be true, but you can always save your bacon after the fact. So which one is the one that after you've built your circuit, if it doesn't work, you just basically have to build a new circuit? Well, what things do you have control over? Well, typically you have control over the clock period. In other words, that's an externally supplied signal when you buy a processor. And in fact, Intel happily sells you processors that run at 2.5 gigahertz and 2.9 gigahertz and 3.1 gigahertz. What they've done is they've actually chosen from their manufacturing line chips that work better and sell them to you for more money with a higher clock rate. What they've done is that they've been carefully testing the circuits to see what their actual propagation delays are. And then they pick a clock period that makes the second timing constraint true. In other words, simply by changing the period of this external clock, I can make the second timing constraint true. Right? Because it is, the hardware will have whatever delays it has, so the setup time and the propagation times, that's what the hardware will have. But whatever it is, you can make clock period big enough that everything that has to happen between rising clock edges does. But what about the first timing constraint, the contamination delays? Well, if you don't have enough contamination delay, then in fact what will happen is the circuit will not work correctly, and there's no clock signal involved in that first timing constraint, right? I mean, if that is broken, you basically have to redesign your circuit to provide sufficient hold time. Right, so this is where computer-aided design tools come in. People spend as much time verifying the circuits these days, in particular things like these timing constraints, as they do designing them, and in fact, sort of a sad truism of hardware design that most of your time you're checking to see if you got it right. That getting it right part is fun. Checking to see that it is actually right is somewhat tedious because you have to check a zillion cases. You have to check this is true for every pair of registers that are connected by paths in the circuit. So it's quite, if you have millions of bits of register in your circuit, that's a lot of checking. So the contamination delay constraint, you have to get right in your circuit design, otherwise you have to redesign the circuit. The second constraint, your boss is upset if it's a 2.1 gigahertz processor instead of a 2.5 gigahertz processor, but you can say, look, the good news, at least I can make it a processor. I don't have to throw it away and say, gosh, sorry, maybe next year we'll have a processor.